Hello, Calculus 1 students. We're in Chapter 2. I'm moving into Section 2.4. We're working on limits. And I already mentioned this in a previous video, but one thing in 2.4 is this topic of one-sided limits. And so I wrote a few things on the board here. The limit of a function f of x as x approaches c with this little negative sign on the back side of the c is not a negative sign, it's not a negative c, it means as x approaches c from the left. So I'm approaching some number c from the left, and that's a one-sided limit. I'm approaching from the left. Sometimes I get my left and right backwards, that's not good. I'm approaching from the left. When we have this little notation, the limit of f of x as x approaches c with a little positive sign on the back side of the c, that means as x approaches c from the right. So these are one-sided limits. Everything before we learned these notations, everything without those notations of the little minus sign and plus sign, they've always been two-sided limits. We've been approaching from both sides. And we've run into some problems where coming in from one side and coming in from the other side didn't match up. The answer was does not exist. Those two-sided limits have to have the same answer. They have to have one answer. But that's the notation. It's easy to quickly say, hey, that's the notation, and then proceed. I'll do a couple quick examples, and then this video might be short. We might. The other big topic in 2.4 is called continuity, where we talk about a function being continuous or not, and we might use these limits and other limits. So there's more to section 2.4. That might be a longer video, next video. But check this out. If I'm working on this function, here's a function called x squared. And then I ask these questions. Now the truth is this is boring. I mean, this is just a nice x squared. It's a beautiful, you know what it looks like. And as x approaches 2 from the left, and as x approaches 2 from the right, and as there's really no difference in the answers to these questions. The questions themselves are different, though. I mean, I'm approaching 2 from the left, and when I approach 2 from the left, but basically I plug in a 2, and what's my answer? 4. I mean, you know the picture. I'm approaching 2 from the left, and you know the picture. This is just a parabola, and there's nothing interesting going on. As you approach 2, you approach a y value of 4. So whether you do that from the left, or what about from the right? You approach 2 from the right. You just plug in a 2 and you get 4. And back when we used to before we learned those, we used to do this limit. Just plug in a 2 and you get 4. So there's times when this doesn't matter, or it doesn't matter to the answer. Coming from the left, coming from the right, or the two-sided limit, and they all have the same answer on a nice continuous function like that. No holes, no asymptotes, no weird things. Okay, so when it does get a little weird, and we're going to have to, was when we have a piecewise function. And so this is a function defined in two pieces, and we're going to work a lot with this in 2.4 because these are good. This is a good way to have a discontinuous function because this function g is defined to be x squared plus 1 when x is less than or equal to 2. It's defined to be this, 5x minus 3, when x is greater than 2. When I read a piecewise, it's broken into two pieces. It could be broken into 3 or 4 or 5 pieces. When I read a piecewise function, my brain wants to focus, I focus over here on what these directions are. So to the left of 2, it's something, and to the right of 2, it's something else. Now the question is, at 2, are they matching up, you know? And to answer that question, I want to do these 3 limits, or I want to do these limits. So here we go. If I'm doing the limit of this function, g of x, as x approaches 2 from the left, you see the little negative sign, it's subtle. When you approach from the left, now hang on, you're approaching 2 from the left, that means you're less than 2. If you're less than 2, you're kind of up here with this situation, with this piece of the piecewise function, and go ahead and plug in a 2. And you get 4 plus 1, you get 5. So I think the answer when you approach the limit as x approaches 2 from the left of this function is a 5. Here's another question. The limit of this function as x approaches 2 from the right. As you approach 2 from the right, you're approaching over here. You're approaching on the right side of 2 from the right. And you're bigger than 2. And if you're bigger than 2, I think you just plug a 2 in there. Remember, we're doing a limit, so I know there's no equal to sign here, so I'm not really just I'm doing a limit as x approaches 2 from the right. So I'm at 2.1, 2.0001, 2.000001. Basically, the way I figure that out is I plug in a 2. But because I'm on the right, I use this piece of the piecewise function. And when I plug in a 2, I do the math. 10, 2 times 10 minus 3 is 7. That answer's 7. So those guys have answers. But because they're different answers, what's the answer to this? The limit as x approaches 2 of this function. And I really, the way to answer this question is to do both of those questions. And when you realize that the limit from the left is 5 and the limit from the right is 7 and they're different answers, then what do we say about the limit of the two-sided limit? And the answer is does not exist. Now, if those were both 7s, this answer is 7. Those were both 9, but all right, so like I said, we're going to discuss continuity. And by the way, this function is not continuous. Now what I got is a kind of a visual of this function. I mean, I don't really care about all the details, but as we approach 2, from the left, we were approaching 5, and from the right, we were approaching 7. So we have this disconnected function again. I kind of colored it in incorrectly there, sorry. I wasn't going to get into all the details. Actually, that's a line over there. This is a curvy parabola over here. But the point is, it's broken because the limit from the left and the limit from the right don't line up, and there's a big break in there, and that's a discontinuity. Again, discontinuities, that's the next topic here in 2.4. So we're still in 2.4, but I'll do that video, and there's a lot to talk about there, a lot of good examples. These one-sided limits are also important up in 2.5, section 2.5. And by the way, then we're getting toward the end of this chapter here. So there isn't too much more to say about limits. All right, thank you.